Hello, everyone, and thank you for joining us today for our HashiCorp Solutions Engineering Hangout hosted by Dave Arnold. Today, we are focusing on HashiCorp Vault with Terraform. HashiCorp Vault secures, stores, and tightly controls access to tokens, passwords, certificates, API keys, and other secrets. Terraform enables you to safely and predictably write, change, and improve infrastructure as code. Dave will show how Terraform can create random credentials for your infrastructure, such as databases and compute instances, along with how Terraform can configure access to these resources through the management of Vault policies and secrets. After the demo, we will take live questions from the audience. I also want to note that this Hangout is recorded, and the recording will be made available after post-processing, usually within about a day or two. I'll email it out to all of you. The demo will be 15 minutes and will allow up to 30 minutes afterward for questions. So with that, let's go ahead and get started. Take it away, Dave.
All righty, let me go ahead and share my screen. Yep, perfect. All right, so today we're going to talk about security in depth with Terraform and Vault. During this demo, we're going to discuss some basic principles for securing Terraform state. We're going to discuss secrets generation and management with Terraform, showcase dynamic secrets engines with Vault, and demonstrate Vault Terraform integration. So if you're dealing with security in depth, you want to make sure that everything is secure, including your data. Terraform itself will generate some files when you're using it, your TF state files, your modules, and all that. You want to make sure that you have secure. Here we're seeing that we're actually creating a random password, and you'll see that the random string.password ID in this blob of a state is actually showing that password. So you want to protect your state files just as much as you do your secrets, because your secrets will end up being in your state file. So there's a couple of ways you can protect this. One is make sure you don't check it in. So this is showing a .git ignore file, and whatever version control software you're using, they should have an equivalent. I know Perforce has a p4.ignore type file as well. And you basically just want to make sure that you're ignoring your TF state file, your TF bars, and you should be ignoring your .terraform directory as well. You also want to make sure that your state file is encrypted and that access to it is controlled. So there are a few different types of remote state that you can use in Terraform. The three that are listed here, GCP, AWS S3, and Terraform Enterprise, they encrypt your state. Terraform Enterprise does it by default. GCP and S3 requires a little bit more configuration within the Terraform config, but it's super easy to set that up as well. And they provide access control as well. So it's a good idea to use these. So playing it safe, just make sure you don't check your state files in the source code, and make sure you're using an encrypted backend that also has some kind of access control. So now that we've secured state, we want to make sure that we also secure access to the infrastructure that we provision in Terraform. So Terraform itself can actually create username and passwords by using random string resource. Here you'll see for the username, we have a length of 16, no special characters, no numbers, and no uppercase characters. But you could configure this to work with almost any password strength type rules that you would want for your infrastructure. So here we're creating the credentials, and we can use those credentials when we're provisioning infrastructure. So you'll see that we're creating an Azure MySQL server here, and we're using the username and password for the administrator login and the administrator login password. We can also upload these credentials to Vault itself. Here you'll see that we're putting them in var.service-name, so that's configurable, it's a variable, and /credentials/database/database name. So we've generated the credentials in Terraform. We've used these credentials to provision a database, and now we're putting these in Vault so that we can get access to the credentials later. we need to create policy to provide access to these credentials. So here you'll see we have a template file that's basically just taking in the service name and the DB name and allowing read capabilities on this path and uploading those as a Vault policy using Terraform. So we've created a database, we've generated our credentials in Terraform, and we've put those in Vault. So already the credentials are pretty secure, but we can actually do better than that. So currently we're using static credentials, but Vault actually has many dynamic secrets backends. So rather than using static credentials, it would be much more secure to use an automated way of managing your secrets. And Vault takes care of this for you if you use a secrets engine. So you'll see that we have listed here a bunch of them. In the demo, we're actually going to be using the database secrets engine. So using the credentials that we've used, we can actually do a little bit more configuration in Terraform and use those credentials to configure the backend connection for setting up these automatic roles. So let's go ahead and demonstrate that. So here you'll see a Terraform Enterprise workspace, and we already have some infrastructure spun up in here. We have the database. I already did this because it takes a little while to spin up a database in AWS, and that's just because AWS takes a while to get that going. So we're going to go ahead and take a look at what's available there. Just 1 second. I need to get my token vault. Okay, so we currently have the static username and password in Vault, right? And that's good, but like I said, we can do better than that. So we're going to go ahead and update this to use the backend for the database. We're going to go ahead and commit our changes, and this will kick off automatically. Once it does, I'll go ahead and show you what we're actually adding to this configuration. All right, so it's running. It's going to take a minute. So let's go ahead and take a look at what we're actually adding. So we're adding a mount that will take care of creating database credentials for us. We're configuring the connection. So we're using the same random string username and password here, and we're using that to configure the database backend connection. And now we have 2 roles that we're allowing our developers or anybody else who has access to read that path. We're allowing them to get access by creating these roles. So MySQL CRUD and MySQL RO. Take a look at what's in those files. So this is a CRUD. It basically just allows alter and create, create, drop, select, insert, just basically stuff you would need to be able to create, read, and update. This is running, just going to take a few moments. So here you can see this is what we're adding. All right, great. So now it's running. And there we go. So it added the 4 items that we need to be able to connect. So you can actually see that here. I gotta put in my token. And now you have your mount set up here. So in your application code, if you have a Vault adder and your Vault token, you can actually dynamically get credentials for your database. So we're going to do that here. This is just a little bit of a setup. This is creating your Vault client. This is reading that path that will give you credentials dynamically in the database. We're grabbing the username and password from that, and then we're logging in and doing just a few operations. So we were able to create this database table just using the dynamic secrets that Vault generated for us. So as you can see, it's incredibly easy to provision infrastructure in Terraform. It's also easy to configure access to that infrastructure in Terraform. So it's definitely worth going the extra mile to think about how you can secure your infrastructure when you're provisioning it. And security should definitely be a topmost priority. And that little bit of work that we just saw by adding this one file should definitely, be considered worth the extra work. Thanks. That concludes the demonstration.
Okay, thank you, Dave. So we will now take questions from the audience, so please feel free to type them in. Any questions you have, Dave's happy to go back and review anything. So I think to start, Dave, the first question, it's coming through right now. So could you show the dynamic credentials that you spoke about?
So I can show you how that was configured, and then I can show you a read, but I'm not quite sure what you mean by show you the actual dynamic credentials. So we created those through these resources in Terraform by using a Vault mount. That's the same as setting up your mounting your secrets engine using Vault, and then creating the database backend connection. Basically says, okay, so on this backend, on this secrets mount, this is how you're going to connect to the database. So we've told it that it's a MySQL server, and so it needs to use that a MySQL type connection versus like a MongoDB. And then here's the username, password, host, and database. Once we have that, then we've actually created these role definitions, and they get mounted under here. So if we do a Vault read creds MySQL CRUD, because that was one of the names of the roles that we had configured, then you'll see that we actually get the username and password here. And you'll see that I have a very aggressive lease on this. I have 30 seconds, which in the real world, you're probably going to need a longer TTL than that. But this is good for a demonstration purpose because you can actually watch it expire. When it does expire, Vault will take care of wiping out these credentials for you.
Awesome. Okay, thank you. And I think that answered what they were looking for. And then the next question, someone's asking, Dave, does Packer have a similar integration with Vault yet?
Not that I'm aware of.
Okay.
Yeah, I mean, you could probably use API calls directly into Vault to pull your credentials out of there. So yeah, if basically any application that you need to integrate with Vault, you can do that via the API. So if there aren't like built-in integration points inside of there, then you can wrap it with that. And that's fairly common with Packer type things, is that you might have some external integrations that you have to do through API calls.
Yeah,
Okay.
and I mean the Packer config is JSON after all, so I mean you could have something that creates your Packer config as well with those secrets.
Awesome. Okay, thank you. And that was Jake, one of our other solutions engineers, who's on the line helping out today. So next question, Dave, is Vault compatible with PHP applications?
With PHP applications, yes, absolutely.
Okay.
If you go to, here, I'll just show you a quick Vault API library. We have a page that's got all of our, various libraries and community libraries, and PHP, you can see, has quite a few actually. Yeah, I mean, there's quite a few libraries that you can use for PHP.
Awesome. Okay, thank you for showing that. And next question, are you able to configure Terraform Enterprise to use Vault for workspaces credentials or workspace credentials?
I'm not entirely sure what you mean by workspace credentials. I was using Terraform Enterprise to launch my Vault cluster as well as accessing my external Vault cluster. The variables in a Terraform Enterprise workspace that you mark as sensitive, those are stored in an embedded Vault server. So, I mean, Vault is used quite a bit in Terraform Enterprise, but as far as your Terraform credentials, not entirely sure what the ask is.
Yeah, I mean, I think that's a lot of different type of questions. So if you're asking whether or not you can use Terraform Enterprise to store things like AWS keys or the actual credentials for logging into something, then yes, and actually those would be set up as sensitive variables. There are some other patterns there as well, but we may need some clarification on what exactly those credentials are used for.
Okay.
We can take a look and see.
And the person who asked that, please, you're welcome to clarify what you're looking for in another question, and we can get it answered for you. Okay, so then in the meantime, moving on to the next question. So Dave, someone's asking, can you talk about Vault's first trust only principle? They're saying they don't remember the exact name, but they're interested in the concept, and they'd like some clarification if possible.
Are you referring to secure introduction of that first secret? Basically, how do you get secrets from Vault securely? I mean, the token itself could be dangerous if it gets out. So there's a bunch of other mechanisms. Depending on your cloud provider, there could be a way to authenticate with Vault. Just with that, like with IAM, for instance, you can, any instance that you have that has an IAM instance profile, you can use that as an authentication. You can use app role. So when you bake your images, either your AMIs or your Docker images or anything like that, you can provide one half of an app role login and then the other half during runtime. So I mean, there's a number of ways to authenticate with Vault securely, and once you've done that, then you have access to the secrets.
Awesome. Okay, thanks. Yeah, my guess is that's what they were looking for, Dave.
Yep.
So next, someone's asking, what authentication is allowing your Terraform to communicate with Vault?
Currently, I'm just using the token. And to be honest with you, I'm actually using bad practices because I'm actually using the root token, which you absolutely should not do. For demonstration purposes, though, it is pretty easy to set that up. I wouldn't suggest doing it that way. There's a number of ways that you could set stuff up. If you're going to be doing any kind of trickier authentication or using, generating tokens in Terraform, you do need to be aware that Terraform itself will actually create a new token for you. So whatever token or authentication method that you pass it, it needs to be able to create child tokens. So yeah, I'm just keeping that in mind. Almost any of the other authentication methods are available.
Okay, great. So perfect, thank you. Next question, are the secrets stored in Terraform state as well as Vault?
So the ones that we generate, like when I showed the random string generating a username and password, that was stored in state because Terraform generated that, which is why you want to make sure that you don't check in your state file, and you want to make sure that you have it encrypted at rest and you want to make sure you can have some kind of access control around it.
There are actually patterns out there where you can do references through from Terraform into Vault and actually have Terraform call into Vault for those secrets so that you don't have to store them inside of your state file. There are, I think, within the Vault guides or possibly the Terraform guides that we have inside of our GitHub pages, there are some patterns that are out there about how to do this kind of state management file. And when I think we can probably post the links for those in the question and answer forms when we get to them. But I don't have them readily available right now.
Okay, thank you. Yeah, Jake, if you guys want to send me those links, I can include them in the recording page that we post on our website as an extra resource for everyone. Okay, and so next, what are the benefits of Vault versus AWS Secrets Manager, Dave?
Yeah, actually, I could take that one. So it really depends on what it is that you need to do for your application. So AWS Secrets Manager has, it's really just a key value store for secrets. There is some rotation that's available. RDS rotations are built in. If you have other rotation for secrets, then you actually have to write your own Lambda functions in order to do rotation for those particular secrets. And our concept of dynamic secrets are not the same as rotation. So rotation means that you're going to be using one of a couple secrets that have common names and then just flipping back and forth between those. The concept that Dave just showed in terms of dynamic secrets, we're actually creating the secrets inside of the target database or inside of target applications. For instance, we could create AWS keys on the fly, so we actually create those on the fly. And then on top of that, we actually assign lifecycle information into those secrets. And so it's not a rotation-based thing. Those things are able to be retired. You can actually you can do full revocation of entire secret trees and chains. And then on top of that, Vault has many other features that Secrets Manager doesn't. So we've got PKI management, we've got encryption as a service, and like I said, the dynamic secrets, SSH, CA generation. So Vault's more like a Swiss Army knife for secrets. The other piece of it too is that you'd have to operate things through AWS, and in some cases, for people who have extremely secure environments, they may not actually want to store or run their secrets inside the cloud. And so are probably some of our largest enterprise customers are usually like financial organizations or large enterprises that do not want to store those types of secrets on the cloud. If that works for your workflow, that's fine. If you have application secrets that are AWS native, then Secrets Manager or something like Parameter Store could be a good option for you. But again, Vault is a far more flexible solution in general. It scales extremely well, and it's highly performant.
Okay, awesome. And then Jake, on that note, someone else is also asking to clarify, can you walk through the differences with Azure Vault?
Oh, to be honest with you, I haven't done any comparisons with Azure Vault. I think that's probably something that we'd have to answer in an upcoming webinar or possibly there. But yeah, it's a good question. I'm not familiar enough with Azure Vault to answer that question.
Okay. And then next question, this is a good one. Is it possible to run Vault within Kubernetes, or would this be advised against?
Again, this really comes down to what your security restrictions are. So, if you look inside of our Vault webpage, there's some best practices for how to run Vault clusters. If you're okay with relaxing some of your security requirements, you absolutely could run Vault inside of a container. We highly discourage this for people who want highly secure environments, just because of the fact that there are a lot of unknowns underneath the layers of both the container mechanism plus how things are scheduled within Kubernetes. So be very, very careful. You can absolutely run a Vault cluster inside of Kubernetes. You can run anything inside of a container. Just be cognizant of the fact that if you have high security requirements, that you're probably not going to be meeting those requirements by running it inside of Kubernetes.
Okay. And so next, someone's saying, so they see Terraform uses Vault as a resource and holds a secret. Can it also create tokens and pass them on to the resulting VM through variables or should that be scripted?
Yeah, there's quite a bit that you can actually do with the Terraform provider the Vault provider in Terraform. You can create tokens. Terraform itself does create a token. So whatever token you pass to Terraform or whatever authentication method that it gets, the token that it receives, it has to be able to create a child token. But yeah, I mean, there's all sorts of resources that are available. There's actually really good coverage between the Vault API that you can leverage within Terraform. And if there's things that you want to do within Terraform that you can't seem to do with like any of the native resources, you do always have Vault Mount and Vault Generic Secret that you can do stuff with that as well. So.
Okay, great. So now they're saying, so say I want to use Vault to handle my production configuration deployment. For instance, production AWS API key secrets. Can I use the same approach as shown in this demo, mounting the volume to the instance, or is there a different way that the Vault community would suggest? Do you need me to repeat that?
So you're not really mounting a volume to an instance. This is a little bit different. Mounting in the case of Vault is about configuring a new type of secrets engine, whether that's a static secrets engine or a dynamic secrets engine like what we've shown with the MySQL. With AWS credentials, you can absolutely get your credentials for AWS through the Vault provider and pass that to your AWS provider. As a matter of fact, I have an example of that here at the Vault AWS account. So if anybody wants to take a look at this, all this stuff is checked into public repos. So you can go ahead and take a look and see what that is actually doing. But yeah, it's creating AWS credentials on the fly and passing that to the AWS provider.
Okay, perfect. So, okay, we've got one more question, unless anyone else wants to quick add theirs in. So Dave, someone's saying, so the IAM keys provided to a workspace when provisioning resources in AWS, are those keys able to be generated by Vault versus statically having to define them? They're trying to avoid having a static IAM user defined against a workspace.
Yeah, absolutely. That's actually what this workspace is doing is instead of passing in IAM credentials, I'm passing in a Vault token where the policy that's bound to that token is able to read from an AWS Dynamic Secrets backend and pulling those credentials and passing that to the AWS provider.
Okay, we got one more question. So someone's asking, does Vault integrate well with Jenkins without having to use the root token?
Yeah, absolutely. I mean, I'm sure there's some community plugins as well that enable that.
Yeah, use the app role. Anytime that you're integrating applications with within Vault, you can use the app role secret engine to do that. So there are a ton of different examples within our Vault guides, both on the website and our GitHub site, that have very, very rich examples about how to use app role to do secure introduction for your applications.
Okay, perfect. Okay, thank you, Dave and Jake, for going through all those questions for everyone. I hope everyone enjoyed today's Hangout and has a better understanding of how you can use Vault with Terraform. Thank you for joining us, and a big thank you to Dave for his time today. As I mentioned at the beginning, this Hangout was recorded, and we'll make the recording available on our website after processing. I will send an email out to everyone who registered with the recording link. You can also keep your eyes out on Twitter, where I'll post it usually later today. That wraps things up for us here. So have a great day. Goodbye.